Hi learners, this is Ma'am Jen Ala, your science teacher on this episode.
For today's lesson, let's talk about waves as carrier of energy, especially the types, the characteristics, and a part of it.
So here are the melts and the objectives of our topic.
First is to infer that waves carry energy. Second, describe the characteristics of sound using the concepts of wavelength, velocity, and amplitude.
Now, to start our lesson, let's try what I know. When you tap the water with your finger, the waves spread all around. When you play the guitar, waves created through sounds. When you turn the lamp, the light spreads all around. Water, sound, and light waves differ in important ways, but they share the basic properties of wave motion. Repetition of movement that cause wave is created by vibration.
Vibrations are the origins of waves. When vibrations disturb a medium, the disturbance travels through the medium from one location to another in a form of a wave. A wave is a traveling disturbance that carries energy from one place to another with or without a medium.
A medium is the materials that carries the wave. It is where the waves travel. Let's observe this picture. If we put the slinky on this position, we observe that it's on equilibrium or at rest position. It is not moving. But if we move the other side of the slinky, you have noticed that the disturbance travels side by side. Which is the medium in this video? Correct, that it's the slinky who carries the wave. Wave is also described according to the presence of medium. When the waves requires medium to propagate, that is mechanical wave. Examples are the wave of the rope, sound waves, and the waves that you see in the water. But when the wave did not require medium to propagate, that is electromagnetic waves. Examples are the radio wave, X-rays, visible light, and more. They are listed in electromagnetic spectrum that you will discuss in your next level. Aside from the presence or absence of a medium, wave can classified according to the direction of vibrating particles. It can be transverse, longitudinal, and a surface wave. Let's talk first transverse wave.
Transverse wave, a wave in which particles of the medium move in the direction perpendicular to the direction where the wave moves. The example of this is the wave in a rope. Next is longitudinal waves, a wave in which particles of the medium move in the direction parallel to the direction where the wave moves. Example of this is the wave in the slinky or a sound wave. And lastly, the surface wave, a wave in which particles of a medium undergo a circular motion.
To understand more about the wave, let's proceed to its part. Take a look at this picture. The dashed line drawn through the center of the diagram represent the equilibrium or the rest position of the wave. The crest of a wave is the point on the medium that exhibits the maximum amount of positive or upward displacement from rest position. The trough of a wave is the point of a medium that exhibits the maximum amount of negative or downward displacement from the rest position. And the wavelength of a wave is simply the length of one complete wave cycle.
Frequency is the number of waves passing through the given point in 1 second. The unit of this is hertz. Next is period. It is the time taken to generate one complete wave. The unit of this is second.
So, that's all for today. To test what we have learned from this topic, let's answer what I have learned.
Let's answer the following question. 1. The maximum distance that the particles of the medium carrying the wave move away from their rest position. And the answer is amplitude. Correct. 2. What types of wave is in the picture? Correct. That is transverse wave. How about this picture? Good job. That is longitudinal wave. Number 4. The materials through which a wave travels. Nice! The answer is medium. And last, the distance from trough to trough or crest to crest. Excellent! That is a wavelength. Congratulations, kids! You did a great job.
Now, let's summarize our lesson. Thank you again, learners, for listening. See you again next episode. Bye!